basically. Okay, so that's recording, I hope. Let me just double check.
Are you going to be recording
Yeah.
it, or should one of us also do that?
Uh, you can if you want, but I'll probably use my recording for YouTube because I just think, I don't know, the audio seems better locally when I do it that way. But
When
yeah, feel
last
free to
time I
make a
recorded
backup.
your shit, my audio was fucked.
Yeah, and that
Yeah.
might have just been a configuration thing. Maybe not necessarily an internet
Yeah,
thing.
is that a fat issue or is that a Ben issue?
Right,
It's probably
right.
it's definitely a my issue.
Yeah. Okay, let
Linux,
me.
dude, Linux uses an audio.
Right.
Oh, dude,
God.
my fucking ThinkPad dock, like the monitors just stopped fucking working. Like, it didn't even
The
update shit.
fuck?
Like yesterday, they said like I update all my shit Monday, and then like Wednesday, it just like I plug it in, and then like the monitors just aren't detected at all. Xrandr doesn't detect an additional provider, and it just like literally didn't change shit. I reboot
Okay,
it,
what the
and
fuck?
it's shit is fucked.
Oh my
I have no
God.
clue
What
what the fuck is the issue.
what the hell? Because that just sounds like a kernel fuckery issue or some shit. But
Yeah,
you didn't
there's like
update it
two
or anything.
threads. There's like two threads on the Arch wiki, but like their solutions didn't all relate to my shit because they had like NVIDIA drivers, and I have like
Oh,
an Intel GPU, so it doesn't really fuck it up. Like their shit was just like updating NVIDIA drivers, or reinstalling NVIDIA drivers, but it's like my ThinkPad doesn't have an NVIDIA GPU.
Hmm.
Anyways,
Okay. So let's get started. Oh, that's funny. Okay, I guess that'll pop up in the recording. That's cool. Um, so today we're going to talk about Docker. This is a very, very general overview of Docker containers. We'll talk a little bit about different things related to Docker, how it works, what you can do with it. This is the old logo, by the way. They changed it for whatever reason. I kind of like this one better, actually. So let's just talk about some goals. We'll talk a little bit about virtualization and how that applies to containerization or how it's different. We'll look at the technology between the Docker client and the engine and what that engine is comprised of. We'll talk about images. We'll talk about images a little bit more. Containers kind of briefly. We'll talk about how images are applied to containers and how just containers can be used in clusters such as Swarms or Kubernetes. We'll talk a little bit more about Docker Compose and how that helps us. And then we'll just do a couple examples that are really simple. And then ideally, I was going to try to do something like where we Dockerize something, but I'm just actually going to show you an example, uh, which will be Pascal's example, which would be pretty fun because that could be potentially applied to the server, which would be pretty cool. This book on the right here was my reference for this. Had some pretty good reviews. Docker Deep Dive. Definitely recommend it. And it's a little outdated. It's 2 years old, but most of it's still relevant. Reading through it, it seems like nothing was totally off. So let's get started. So what is a virtual machine and what is a container? So we know that virtual machines run on the hypervisor, right? And there's some higher latency there. And part of that is you need a dedicated operating system within a virtual machine, right? So you're not only that, but you're allocating resources from the host. So what do I mean by allocation? Well, you're allocating memory space, so the RAM. You're allocating a CPU or maybe a couple virtual cores. You're allocating storage space, and you can dynamically size that so that it doesn't take up as much space. But ultimately, when you're running that machine, that's what that virtual machine has access to. So it takes up a lot of resources to run a virtual machine compared to a container. There's also possible dependency issues with operating system updates. So if you're running an application on a VM and there's an operating system update that comes through that breaks something, that could potentially affect your application, especially if it's a web application. And then there's dealing with security upgrades and what that potentially may break for you. And just to give you a little bit of background, we know that virtualization replaced bare metal servers, right? So back in the day, uh, companies would have applications on the internet and they'd have a lot of traffic and then their servers would just be overloaded and they want to upgrade. Well, what do you upgrade to? How do you predict that traffic? Especially if you're talking like 90s, early 2000s, It was hard to figure that out. So people just spent a lot of money on servers, and they kind of went overkill on just spending a lot of money on servers to self-host. VMware came around and they made virtual machines, and that kind of became what stood on top of servers at the time. There's more history to that, so I'm just kind of giving really general background. Virtualization really helped with that. It isolated the applications from each other. So you can boot up one VM and then boot up another VM, and you can use that same template to clone the virtual machines and have your application running in two different places, which helps with load balancing if you're an application on the web. So that's virtualization in a nutshell. There's more to it, of course, but if we look at containers, we'll notice there's some differences. One, we don't need a dedicated operating system. We share the host operating system, which is pretty cool. How do we do that? Well, we're actually just we're becoming a process. We're becoming a part of that process tree, and at least if you're thinking of Linux, we're just becoming another process. And we're being abstracted away so that we're isolated from the main running processes. So you've heard of something like Docker Escape. So that does happen, and depends on your configuration, but it doesn't happen nearly as much as you think. One thing that containers have over virtual machines is that they're much more portable. Cloning virtual machines takes a lot of time because they take up a lot of space. Containers are really small typically, and usually it's actually easier just to build them over and over again. And they're easier to start and restart, just because they're sharing the host operating system resources, right? So they're sharing RAM, they're sharing hard drive space, so you don't have to allocate anything. You have to make sure that you have enough just in general for all of your containers on the server, but there's different ways of orchestrating that when you have a large number of containers. So in this case, containerization replaces virtualization when we don't need an isolated operating system, right? We can bundle all of the services that we need into containers. So ideally, each service gets its own container. So for example, if you have a web application, you have the front end on one container, you have maybe your database on another container, maybe you have API calls going through another container, you have a networking container, and all of those kind of interoperate together. And just generally speaking, we try to containerize applications, right? That's what the goal is, and that's good for security. It's good for just resources, and it's good for just keeping uptimes really high, right? If you're running a web application and one container is seeing a lot of traffic and you have a load balancer, it could just go to another container. And what's really cool is that you can actually configure another container to be built if there's more traffic than it was expected. So there's a lot there. We're kind of jumping ahead, but just to give you an idea of some of the differences. There's room for both. There's room for virtualization and there's room for containerization. Containerization does not replace virtualization. It's just it's a corollary, and there's different reasons to use it. So we're going to get into how Docker works a little bit. Again, we're not getting into low-level code or anything. Just kind of just overview of the Docker engine and its components. So we're going to look at the Docker daemon. So I don't know if it's daemon or daemon. I just say daemon because that A kind of screws with me. Then we have containerd. Containerd is a really important one. It's added a lot of functionality over time. We'll get into that. And then we have runc. And then just on the sides here, we have Docker client, which is kind of just your command line commands. And we have plugins. We won't really talk about plugins, but just to know that that's also part of Docker as well. So what is runc, right? It literally just creates containers. It's the creation process. So it's known as the lightweight command line wrapper for libcontainer. Okay, what is libcontainer? Well, libcontainer was a replacement for Linux's LXC. And the idea, the Docker company, Docker Inc., they wanted Docker to be platform agnostic, right? They wanted it to run on Windows, Mac, whatever, Linux. What LXC did was that it provided a daemon for things like namespaces and C groups, right? And there's a lot to go into with namespaces, so I just left a reference here if you're more interested in it. There's some general namespaces listed here, PID, NET, some that you recognize. And its job is really
Quick
just...
push.
Yeah, go ahead. Yeah.
What is Linux LXC?
Linux LXC was just a basically piece of software that helped abstract away from the main process. So this is like the isolation process, the isolation piece of Docker. So when you tell Docker to create a container, LXC, or well, really libcontainer, which was LXC, they're basically synonymous. It's just Docker's version of it, but for all platforms. Docker tells this runc to create it and create it on a different process, right? So like when I say process, I mean like one of these. So if we look at our namespaces here, we're kind of separating out from our normal trees here. So I tried to get the tree view. It's not great. I should have had a Docker container running to actually show it. So I didn't do that. But ideally, it'll be branched off this tree and it'll have its own kind of child processes here. So it's pretty similar to like how most applications run. So you'll see Chromium and Firefox are like that because, again, like web browsers are sandboxed, or they're supposed to be. So that kind of gives you a really brief look at just namespaces and how runc operates. It's operating at this level. It's really creating the process for creating a container. Containerd, really the only intention for Containerd initially was just to manage and supervise the lifecycle operation. So we're talking start, stop, pause, remove. That was the intention, although it took more functionality over time. So Docker introduced image pulling from its repository, so Docker Hub. It introduced volumes. It introduced networks so that you could network containers together. What's great about this, though, is that it's all modular functionality. This particularly helps in Kubernetes, but this modular functionality lets you choose the functionality you need in Containerd and to kind of leave out what you don't need, hence kind of reducing the overall size of Containerd. Just the actual runtime of it as well, build time, I guess, really. And we know that this sits between runc and daemon. Daemon, so this is what allows the container to detach from the controlling terminal. So, if you start a Docker run interactive terminal and you run a container, it's not going to stay in a container. It's not going to stay in that terminal. It's going to branch off into a background, basically. So it runs as a system daemon. It uses gRPC API, so that instructs the Containerd to start a new container, and then Containerd talks to runc to help get that process started. And we're going a little bit backwards here, but Docker, the command in command line, right? We're saying Docker build, right, or Docker run. We're actually, what we're doing is we're sending an API payload in a post request to the endpoint that's exposed by the Docker daemon. So that Docker daemon is kind of always looking to just process API requests to kind of start the process. So it goes command line, sending to an API endpoint by the Docker daemon. Docker daemon instructs Containerd to start a container, start building it, and then runc is actually starting to build it and allocated a process ID. So that's just the Docker engine in a nutshell. So we're able to understand how containers are built. We're going to get a little bit into more about the inner workings of containers now. And containers really are just multiple groups of images. You can actually have just a container on its own with like a single image, but most of the time you'll see multiple images. And you can think of this as a template as well. So often you think of VMware, when you set that up, we set up a template where we're allocating resources. This is a little bit similar. Might be easier for people to think of it as a class. And this is kind of where we get into build time constructs versus runtime constructs. The build time constructs are where you're initially setting up what's going to go into the container, and then the container is what's actually running, right? That's the runtime construct. It's all the components that were included in the image. And these are typically read-only layers, these images. They're small, and they're independent of each other, right? So it's the files, it's the code that will all kind of be grouped together in the container. We know that images are identified by some sort of ID. So if you do a Docker pull of an image, you'll notice there's maybe a SHA-256, and there's these content hashes that persist, and I think it's usually like the first 12 characters of the hash, something like that. So then when you do a Docker run, you can either use the name of the container or you can use the image ID, content hash. And just to give you an idea of overall size, if we think about VMs, right, just the ISO alone for like an Ubuntu server, I think is, 800 megabytes, maybe a gigabyte. It's not that big for a VM, but the smallest Alpine Linux image, where you have like an actual file system, is 5.54 megabytes in size. So that's pretty cool. So you can use Alpine Linux to build off of just a small, like bare bones Linux kind of file system there. So I listed the Docker Hub as the kind of main image registries. There's actually more than Docker Hub. I mean, you can even use, if you really think of it, you could probably even include GitHub in there, although it's not really intended as an image registry. Docker Hub is an image registry in that it also validates changes. So hence we go back to that hash of the configuration. If there's changes that are made by a person who initially uploads an image, they hash it, and then whenever somebody does a Docker pull, they rehash it to see if anything changed on transmission. And similar when you do that in the command line, it's doing that hash. So we'll see that in a little bit when I do a demo. Not really a demo, just kind of an example. So again, this is basic kind of like when you start a virtual machine from a virtual machine template, where we can similarly start one or more containers from a single image, right? We're talking about just a template build file. Images are kind of the building blocks for containers. It's useful to think of containers performing operating system virtualization versus hardware virtualizations, because we're kind of carving into virtual versions, i.e. the containers. Okay, that's, again, a really quick run through of just kind of images as containers, how that works. I'm going to look at Docker Compose really quickly. So Docker Compose is great. If you have several Docker containers that you need working together, it's really useful to use Docker Compose instead of having multiple Docker commands that are all issuing at once. You can just reference a Docker file or a YAML file, and this will detail everything about your web application. So it'll detail the type of container it is, the version, all of the software that you want included, the package manager that you're using, and it'll just build your Docker containers from a single YAML file. YAML file, if you're not familiar with YAML, YAML is just a subset of JSON. YAML is pretty easy to notice, but it's very similar to JSON. Okay, so for some examples, I'll do, I'm going to just pull from Docker Hub so you see what that looks like. And I'll also do a git clone from, from GitHub so you can see what a Dockerized app looks like. I kind of jokingly put malware free or free malware in there. Just make sure you know what you're pulling if it's not from Docker Hub. You never know what's in there. It's good to kind of just read through the code and make sure it's like looks half decent. And then I'll show you what a Docker file looks like, and then I'm going to show you Quizbot, which was Pascal's thing he made for his Pen Testing Plus exam, I believe. And I also contributed to that as well, but I'll show you. I left a list of useful commands here, just in case you take this offline at some point and you just want to see that, as a reference. Again, you can always do go to Docker's documentation page. Docker has a really good documentation, and also just for other operating systems too. So, I mean, I use Linux, but it definitely has decent documentation for Windows and Mac OS as well. Okay, so let's get into just some practice here. So we're going to pull Kali first. So just go to a temp directory here. Is there anything in here? No, okay. So we want to find a Kali image. And you could go to the website and look around, but you can actually do it right from the command line. So let's do docker search. So we're doing docker is kind of the binary using, search is the command we're giving it. And we're going to do just Kali, just see what happens. Okay, we got a lot of options here. Typically, I use Kali rolling if I ever use a Docker container. And we can see that it's cut off here, but it's a weekly snapshot. And if you want to reference that more, you can go to Docker Hub and kind of see more about it. But let's just pull that for an example, and I'll show you what the hash looks like as well. So we're doing docker pull, and then we're going to pretty much copy it word for word. Let me know if I'm spelling it wrong. There we go. Yeah. Cool. Okay, so here's that SHA-256 digest here. So it looks like it's up to date. We have the latest image. So this should be only a couple days old. I think we can actually do docker inspect, docker image inspect. So we do this. So docker image ls. Okay, so we see it here. Here's the image ID. And okay, so it says it was created 5 days ago. So we're getting up to the end of the week for the snapshot. And we see it's only 167 megabytes in size. Now, it doesn't have all the tools, as we'll see. But this is like a base install of Kali. So now we want to get into Kali. How do we do that? We want to start that container. All we do is docker run tech it. And we want to reference this container. So you can do the image ID, or you can, oh god, or you could do the repository name, either one. We could just do the repository name, just keep it simple. And we got to specify a command, so typically we'll do something like bin bash. Cool, okay, now we're in our Kali container. So we can look for the commands we have here.
Question.
Yeah.
What does the bin bash do in this scenario?
So we're telling the container that we want to execute this binary. So you could actually do something really simple, like I believe you can do docker run it. Actually, why don't I just do this?
So are you doing, is that bin bash, is that going into the Kali rolling image, or is that part of the docker run?
So when we say docker run, we're telling this to run this image as a container, right? So so it's actually only existing for the time that we have it in our terminal. And then when we exit it, the container is stopped. So it's done automatically. But so we're just executing a binary, but we could actually do something else. Like I think we could just do this. So it'll start really quickly and then stop once it prints this out. I believe this will work. Actually, I got a reference. Is who am I a shell command, or is it a... I should know that. I'll do it anyway. Cool. Okay, so it ran that container really quickly. It only ran this command, and it prints out who we are. So if we want to let it persist a little bit more, let me do this and see if we can show the container running. So docker container ls. Okay. So there's a couple different things running here. So it tells us our status. So this was up 8 seconds ago. It was created 9 seconds ago. It tells us our container ID. Tells us the command we're running, which is pretty cool. And what's cool is that they give us some unique names. So instead of referencing the image ID, we can actually, a container ID, we can actually just reference the name if we want to include that as we're running along with the container. So we can actually also do this. So we're going to leave this running here, but we can do docker container stop. Oh my god, I forgot the actual There we go. So we're going to reference the name, Zen Benak. Let's see if it stops it. It might not have liked that. Yeah, okay, so you see it stopped here. I don't know why it took so long, but it did actually stop it here. So that's just pulling an image, but we can actually, treat it like a legitimate Kali instance, right? So like I'm using Arch right now, or well, Endeavor, but I typically use Pacman as my package manager. Well, I can use app now, so I could do app install nmap. Just kidding. What did I do wrong? Oh, right. Is it NetTools or something weird?
You gotta run apt update first before you can install
That's
stuff.
right. That's right. Sorry. Yep, I forgot the mirrors. Thank you for that. Okay. And then we're going to install this. Cool. Now we have nmap on a Kali container running on our host operating system. So, I could do something like nmap sc or sc sv. Just do our local host. Actually, whoops. This doesn't really matter. Cool, and it shows, nmap running. So this is kind of the power of Docker, like instead of starting a VM, getting Kali on there, and doing nmap, we can actually just do it straight from our host operating system, and it's isolated, right? It's isolated. Now, if you have issues with like your IP and like you want to hide your IP, it's a different story, but you can do a lot with the container. It's nice if you're doing a web application pen test and like you're on Windows, and maybe you don't have access to the Windows version of nmap, which I think it's called ZenMap or something weird, the GUI version. If you don't want to download that as an executable, you can actually just start a Docker container and run nmap. So it's pretty useful for one-off commands. Funny enough, for the people that love Rust, if we do Docker search, we will find rustscan. So if you want to use rustscan instead of nmap, it's up there. So I thought that was pretty nifty. And the reason I even know that is because I was thinking of Dockerizing rustscan, but somebody's already done it. So it's pretty cool. You can find a lot of cool stuff up on the Docker Hub. Okay, so that is just doing it from the registry. But what does it look like if we do it from GitHub? So let's look at a random... I'm basically taking this directly from Networking Chuck, I'm not going to lie. But I love it so much. I use it pretty much every day. So we're going to look for this thing called SearchNG. And what this is, it's an operating system. I'm sorry, it's a search engine. And it will basically hide a lot of metadata about you when you're searching stuff. And it will also use a lot of other engines in it. So it just randomizes your data and your search data when you're using these engines, right? Because like Google or Bing, they'll basically try to get as much information about you, like your browser, and fingerprint you and your operating system. This basically acts as a proxy. So it has a proxy in there, it has a database for temporary storage, and then has the actual application. So just looking at the GitHub page here, we can see somebody made a Docker version of it, and they include a Docker file. And here's a YAML file for you. And it shows you we're going to have 3 containers running. One of them is going to be Alpine for Caddy, which is their reverse proxy. It's talking about a Let's Encrypt certificate there because you can actually use this Docker container and host it on your own website. So you could have it actually running on with the TLS. This is the application. And then this is just the Alpine image of Redis database here. And you can get into each file and just look at what's going to happen. So each Docker file is related to the service it's talking about. So this is the Caddy server, right? It has its own Docker file. So let's take a look at what this looks like on the command line. So we're going to copy this. We're going to go back to our command line. And we're going to go back to temp and we're going to do git clone, and we're going to get this search-ng docker. And we're going to look into the file folder here, and we'll note that we have a couple different things. We have caddy file, we have docker compose, we have our environment, and this is our configuration file, and this is the template. So one thing you have to do with this in particular, and this is really not related to Docker, this is more search-ng, is you actually have to generate a key. So if we go to our .env configuration, whoops, not there, sorry. He's a liar. There it is, sorry, settings. So if we go to our YAML file here, we have to actually change the secret key. I'm not really going to, but ideally this is what you want to do. But regardless, even if you didn't want to change that, there's one command we have to run, which is the stream editor command here. So this will use OpenSSL, make a random a bit hex digit basically. You shouldn't copy from GitHub like this. I mean, this is okay. It's not great practice to always just copy stuff in, but I'm pretty lazy here today, so we're just gonna do it. Oh god. Right, so go back.
Ultimately, just know what you're copying.
Yeah, that's
Like, don't
that's a good
copy
point.
without knowing what you're not copying. Like, understand what you're copying and understand what it's going to do before pressing enter. Especially if you're using sudo.
Yeah, definitely. Okay, so we ran that, so we now have a secret key there. This will allow it to run. So now if we go, what we're going to do is we're actually going to use Docker Compose this time because we have multiple containers that are going to be created, right? So that Docker Compose is actually going to do that. So let's look at that. Let's look at that. So we have Caddy here. We're calling these services, right? Caddy is a service that's going to be containerized. Redis is a service that's going to be containerized. Search-ng, our actual application, is what's going to be containerized. And a Docker file has multiple things, and what's always necessary is your version you specify. Always specify the version, the services. Some of them are not necessary, like volumes are not necessary. But obviously, since it's a web application and it's using networking, it'll be useful to do that. And here's the other two, networks and volumes, are kind of referenced above as well. We can change things around here, but we're not going to for this example. So again, we're going to use Docker Compose. So it's going to reference that Docker Compose YAML there, right here. And there's one command we're going to send to this, one argument. We're going to say up because we want all of these containers to go and start. And we're also going to specify tacd, which will run this in the background. Otherwise, it'll just print a log to your terminal, and if you don't want that, not necessary, just do tacd. So let's run this. And we've started our containers. It says it's running. I might have localhost already running here, so we'll see. It might get an error. Okay, cool. So there we are. Let's take a look again at our containers. Docker container ls. And we see that we have our containers running. It's showing us the command it's running. And it's telling us the ports it's on. So we know, okay, this is our 127.0.01. The port is 8080. So this is our local host, which we verified here. And this is really cool. So what's cool about search-ng as well is that it sends everything as a post request unless you specify otherwise. Meaning, and that's good security-wise for your personal computer. So all of your parameters, so your search parameters will be in a post request, in the body of the post request. So that'll be encrypted. If you were to do it like other browsers, so if we do DuckDuckGo, for example, when we say testing, you'll note this is a GET request. So we have our search parameters in the URL here above. But if you do it as a post request, it doesn't see anything. We can validate this as well if we do a reload here. Yes, resend, thank you. And here's our post request. So here's the post request, our search. DevTools is not great about showing the body, at least from what I remember.
It's a request underneath.
There we
I'm
go.
pretty sure.
Oh, you're right. You're right. Yep. There we go. Okay, so here's our body for that request. So it's pretty cool for searchng. And again, we're running this from a container. It takes very little resources, and we actually have like a proxy for our searches, so it's good for privacy as well. So it's a pretty useful thing for Docker if we're just doing one-off things. Now, the last thing I'll show you, and if you want to stop your instance of these containers, you do docker compose, since we're still in that file path, docker compose down. And you'll see that's all been removed, and the network's been removed, and we're good to go. So if we were to go back and do localhost, we won't get anything, I hope. Cool. Last thing we're going to do, as an example, is we're going to go to Pascal's.
A quick question.
Yeah. Oops.
Is there any way, so once you down the those, not instances, but the once you down those, is there any way to recover them, or are they kind of just gone forever?
Well, so the containers are the containers are just one-off, right?
Yeah.
You build them when you need them. And when
Yeah,
you
so
don't need
like-
them, the containers, they're runtime constructs, right? So what persists are the images of them. So the templates. So the containers are basically like virtual machines that only persist when you need them to.
Yeah, but like if I wanted to like find out like what commands were run on that Kali Linux image, or what was or what went through that search engine, is there any way for me? Is there a way for someone to go back in and see that, or is it just or is it just gone?
So my initial assumption for at least Kali is that it's gone, because that container was again, it's isolated from the main host operating system. When you run docker run again, docker run it, it creates a totally new instance of Kali. So trying to actually do forensics on that, yeah, I don't think you're going to have much luck.
Okay.
Now, on the other hand, if you have searchng, for example, right, you won't be able to see what you searched for, but if your browser history is such that you record, like sites you went to, like it'll show localhost, right, and it might show searchng's localhost search, like that endpoint. I don't think it has any. It might have cache control. That's actually an interesting point. I wonder if.
I mean,
it does.
ultimately, don't you need a persistent volume if you want like to save stuff outside of the actual execution?
Yeah, and so what's interesting is that they do have volumes, but I don't think they store that way. At least I don't think they did. Let's see.
You could do docker volume ls and see if those volume are still present or not.
But generally speaking, Docker is not very forensic friendly.
Yeah. Yeah. And that's just it kind of in the way it's built.
Yeah.
Yeah.
Okay.
Yeah. Now,
Makes
I guess
sense, thank you.
if you really get into the nitty-gritty, like maybe there would be some like temporary storage in like the RAM. Like I don't. So the one thing I don't know is how Docker's coding is. Like, does it free the memory in such a way that it's like basically overwritten in a certain way where you can't pick up that way? Like if you get like really into forensics in terms of like the hardware, that I'm not sure. At least from the software side, it doesn't seem to persist any data. Now we do have, so Docker volume S does show a lot of volume names, but I don't know if, I'm not so sure about that. I'll have to look into this and see what this is. So that's the first time I've
I'm
seen
pretty
that.
sure that they're just like randomly like if you don't specify a name, it's just like automatically generated
Yeah, that makes
names,
sense.
if I'm not mistaken.
Yeah.
It's a random adjective with a random noun from a dictionary.
Is it really?
Yeah.
Oh shit. Okay. Cool.
Yeah.
Docker exposed.
Yeah.
Okay. Last thing I want to show you, just to give you an example of what you can do. And this is, I mean, I'm saying this is not a great example. I think it's a great example, but there's other really good examples, like entire websites and entire like services out there. What I like about this is, like, for our community at least. So if we go to sorry, that's his README. We go to his repositories and we look for Quizbot. I really enjoyed this. I think it's really cool. It's basically just a Flask app. It's a Python Flask app that's running in a container, and it uses Discord's API to basically make a quiz. So I was going to demo it, then I was like, I better not show my API token in a public Discord. So I'm not going to demo it. But you could do this in your own server as long as you have developer options enabled. And you can kind of mess around with this. So here's our Docker file. It's really simple, bare bones. It's just we're just using Python, and we're just doing a couple of different things. So here's a requirements file for what we're pip installing here. And yeah, so you can add your own quizzes. So this was for the Pentest Plus exam, and you can actually interact with other people. So for learning purposes, I think this is a really good example of just like something really quick and easy that you don't have to like build a website for, right? We can use existing technology and just have this running on like your local system, like, and pretty securely too. So yeah, so that's the end of my presentation. Are there any other questions I can try to help with? Is there something maybe you didn't understand during the presentation I could go back over? Attempt to go back over?
Solid presentation.
Cool.
Yeah, thanks
So,
for the talk.
so I
Not a
mentioned.
talk.
Wait, say it again?
Go on.
So I remember you saying something about like Dockerizing tools. What would be the benefits and disadvantages of doing that compared to just running them natively?
I think the disadvantage is just time, right? Like you have to just, one, know how to Dockerize something, and two, like get it to like do networking well if you're going to use it that way. That's kind of the disadvantage, because you have to have that knowledge. The advantages though is you don't have to have that tool basically operating on your system. So there's some tools that you don't want touching anything else. Like, I'm trying to think of like an example. There was something that we were using at work. Again, one of the main examples is just Nmap, but that's not a big deal because it's just a port scanner. Like one thing I did last time was using the Juice Shop Docker container. And that's pretty useful because we're sending payloads and we're kind of attacking our basically our own computer when we're kind of pen testing that. So if you wanted to send like a file upload and it has like malware in it, you're sending it to yourself, and so it's good to like isolate that. And we were also within a virtual machine as well. But sometimes that's useful if you're Dockerizing like environments. If you want to do testing in, or if you want to test some exploit in. That's kind of mainly what I've seen it for. I mainly see it for web apps is basically what I'm getting at. In terms of tools, I don't know if there's any more advantages. I think it's helpful for other platforms like Linux. I think doesn't have a problem with most tools. I think for Mac OS and for not as much Windows, but definitely Windows, having like Linux-based tools available is not as easy, especially with Windows Subsystem for Linux. Like, for example, Windows Subsystem for Linux version 1 does pretty okay over VPN, and so you can download most of your tools, but it's kind of abandoned. They went to WSL2, but the networking is really screwed up. So like you can't use it over VPN unless you create a like a PowerShell script that executes every time you start your computer. And like messes with the registry. So people don't like that. so it's nice for when you have a work computer, it's using Windows or Mac OS, and you want to use a tool that it's like you can just get it from a package manager and install it. If you don't have Homebrew on Mac OS, you can just use the Docker desktop application and run things that way. So it's more so like compatibility, I'd say. That's mostly the advantage there for tools.
I'd also add for tools and also just in general, allows you to have a clean environment. So if you're doing something for a particular client or like a particular, say, hack the box machine or whatever, you can spin up a Docker image with like your tools or a particular tool with a particular configuration. And then now you have a clean environment where you can run that tool without it being affected by any other data or any other like any other client's information. And it's just like segregated by itself. So you can sort of use it as a jump box of sorts in a local host, or also if you just want to run tools locally that way. That's also another use for it.
Yeah, that's a great point. Thank you. Yeah.
And then also in general, it's easier to do like spin up a Docker Compose than having to, or like a Docker image than having to go and install a full-on program. Especially if it's like a larger application, like say a C2, right? Most C2s will have a Docker image which you can just utilize. Because it's way easier to just spin up a Docker image than having to go and install it, especially if you have to make it yourself, if it has dependencies, if you need like virtual environments because it's a Python C2, right? Etc.
Yeah. Yep.
Yeah, Bad got the meme in voice chat.
Oh wait, I gotta see this. Okay, well I'm gonna stop the recording now. So let's do that.